Okay, so what we've got here is a classic quadratic application problem. This is a ball being thrown straight upward. Sometimes this will be a model rocket being launched or a rock being dropped or any variation of this. It's a projectile motion problem. In this case, the ball is being thrown straight upward with an initial height, from the initial height of 2 meters, which is about 6 feet or so, with initial velocity of 26 meters per second. That's about 60 miles per hour. I'm going to go through a couple of questions here. Sometimes you'll be asked one or two of these questions. I'm just going to go through, three or four questions or so and show you how it all works out. If you have any interest as to where this equation comes from, it follows the general form of a quadratic. As you can see, velocity is put into the B position, and initial height is put into the C position, and the A is the acceleration of gravity, which is 9.8 meters per second squared, and I've taken half of that to give me the negative 4.9. So once the ball is released, our timer begins, and we are first asked to determine the height of the ball when our clock reads 1 second. So I underline that. That's an important piece of information. I'm being given time, 1 second, and I'm being asked for the height of the object. Well, if you look at the variables that are given to us, I'm going to fill in all the times with 1 second, because that's what's given to me. And of course, they're going to ask me for the other variable. They're going to ask me for the height. So if I simply put the ones in here, I'm going to read this as height after 1 second equals negative 4.9 times t squared plus 26 times t plus 2. And you run some numbers through here. And we're going to come up with the height of the ball when the clock reads 1 second. And the trick to this is that when the problem was given to us, we identify what was given, in this case the time, and what is being asked for, in this case the height. And that way we can put our variables in where they belong. We find here that the height at 1 second is 23.1 meters in the air. And that's the first question. So what we'll do here is we'll begin to build a graph of this scenario. As you can see on the x-axis I have time listed, and on the y-axis is height, measured in meters. And the first question is answered by saying that time is 1 and the height was 23.1 meters, and we represent that on the graph. I'm going to move to the second question here. It says calculate the maximum height of the ball. This is a classic. This is probably the most common question that they'll ask us, and what they're asking us essentially for is the vertex. Whenever you look for maximum height, it's going to be a vertex question. Vertex has a formula. We start with the axis of symmetry. X equals negative b over 2a. In this case, we don't have x's, we have t's. So understand that what we're looking for here is a time value. So instead of saying x equals negative b over 2a, we're going to say t equals negative b over 2a. And if you look in the positions, the B position is occupied by the 26. We'll put that right in there. And the A is the negative 4.9. And make sure we keep track of that negative. And when we divide these numbers, we find that the time that it takes in order for the ball to get to its maximum height turns out to be, let's look at this, is 2.65 seconds. Round to the hundredth there. So 2.65 seconds in order to reach the maximum height, but that doesn't tell us what the actual height is. So what we've got to do is figure out, okay, well, what is the height of the ball at 2.65 seconds? And that just requires us to take this 2.65 seconds and plug it in there 4 times, just like we did in the first question. Put this 2.65 in where all the t's go, and just plug some numbers into the calculator here. Notice this is a two-part question, question 2 here, because in order to find the height, the maximum height, I first have to figure out, using the axis of symmetry, at what time does the ball reach the maximum height, and I found that to be 2.65 seconds. Once I have the time, I can go back to my formula and plug it in and figure out what the actual height is going to be at that time. Just plugging some numbers in here. Okay, so I find that the maximum height of the ball is going to be 36.41 meters, and that happens when the clock reads 2.65 seconds. And I'll put that also on the graph so we can start to build a picture of this. This is the vertex of the parabola. It's no different from finding the vertex in any other non-application problem. On the x-axis, I'll mark that's about 2.5 there or so. And the y-axis will go to around 36. And right there, we're going to call that the vertex of our parabola. And that is the maximum height that our ball will reach. I'm going to go ahead and answer a couple of more questions. These are just common questions. You won't always be asked all of these things for one particular problem, but if I go through each of them, you'll have an idea on how to deal with each question, whichever one may come up. The next question I'm going to ask here is, when will the ball land? And this is a bit of a tricky one. The question is when, so I'm being asked for time. And in a sense, I'm being given the height. Now, the number itself is not presented to me, but when they say that the ball is going to land, I can imply that the height of the ball at that point will be 0. It's going to land on the ground. So, in this case, I'm going to plug in for h. They gave me height is 0, so I find the h position and put a 0 in. And I'm being asked for time, so obviously my time remains in the equation. And what I've got here is a quadratic. And I need to solve a quadratic, and there are a couple of options for doing that. Factoring would be the easiest way, but that's not going to work out very well in this particular case. So I'm going to go ahead and use the quadratic formula. And you should be familiar with this formula. You'll have to memorize it for your exam. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when you write this formula out, remember in this case we don't have x's. In the position of x's, we have t's. So again, keep track of what it is that you're actually finding. So I wrote t equals instead of x equals. And I like to write my formula out with empty parentheses where all the variables are going to go. That just helps me keep track of negative signs and keep track of my operations. I find it to be very helpful, so I highly recommend writing your formula out in this skeleton form. Now I can put in my numbers. So the 26 is in the B position. The negative 4.9 belongs in the A position. And of course the C is the 2. And keep track of your order of operations here. We're going to square the 26. We're going to put together, multiply the 4, the 4.9, and the 2. This is a common place where people make the mistakes here is watch out for that double negative. The negative 4 and the negative 4.9 end up giving you a positive 39.2. So be careful about that. Just watch out for your signs there. Now I'm going to combine the two terms that are inside the radical. And in this case, I'm looking for a decimal answer. I was asked for a time value, and I'm going to go ahead and give you a time value in decimal form. So what I'll do is I'm going to, in my calculator, type in a radical of 715.2 and find out what that equates to. 26.743, and replace that radical with that number. And at this point, I have to deal with that plus or minus. which means that I'm actually doing two problems here. I'm going to do negative 26 plus 26.743 and divide that all by negative 9.8. And then secondly, I'll do negative 26 minus that 26.743, also divided by negative 9.8, and I'm going to get two answers. So when I use the plus sign, I come up with a time value of, this comes out to be negative 0.0758 seconds, and you can round that however you're told to round. So we're rounding to the hundredth. Now I'll explain what this all means in just a second here, but let's just go through the math and solve the two pieces. Remember, I'm using the plus and the minus because that was part of the quadratic formula. So I've used up my plus sign. Now it's time for me to do this same equation and use the minus sign. So negative 26 minus 26.743, all divided by negative 9.8. Now keep in mind, the path of this projectile is a parabola. And the quadratic formula is going to find the roots of that parabola. And this parabola has, in fact, two roots. Now, depending on the situation, you may have to throw one of these roots away or just interpret what it is that's happening. The ball lands at when the clock says 5.38 seconds. So let's take a look at that on the graph and get a better sense for what happened with that negative 0.08 seconds. Remember, it's a parabola, and the parabola it opens downward, so it cuts up through the x-axis, reaches its vertex, and then falls back down to the x-axis and cuts through it again. When it came up that first time, it was at the position almost at the origin, but just slightly to the left of the origin, and that's why it's come out to be negative 0.08 seconds. When it comes down and lands, I'm marking it here in green. That's where the ball actually lands, and that's a good picture of our projectile. That negative 0.08 means nothing, but that would be that's called an extraneous solution. It's not applicable to this particular situation. So the answer to this question is the ball lands when the clock reads 5.38 seconds. Those are probably the three most common types of questions that would be asked of you in a situation like this. Another simple thing that they might ask is something along the lines of, from what height is the ball actually thrown? Now, in this case, they told it to us in the beginning, but if that wasn't spelled out for me in the beginning in the sentence, I could calculate it by making the assumption that the ball was thrown when the clock read 0. We want to start our clock after we throw the ball. So if I simply type in time equals 0, I can find out where the ball was at that time. And you see I've plugged in 0 for all my t's, and I come up with an answer of the height of the ball when the clock reads 0 is 2 meters. And you can see that is my y-intercept. And you can do that anytime you're looking for the y-intercept. So I hope that's helpful to you, and I'll see you next time.